Today, class, we're going to be studying rational expressions. We're going to be able to simplify rational expressions, simplify complex fractions, and add, subtract, multiply, and divide rational expressions. To simplify a rational expression, you need to factor both the numerator and the denominator as much as you can, meaning factor them completely. And then you can cancel things out. You might want to try to cancel the x's out like this at the beginning. And you cannot do that. The top term you can think about as being in parentheses, along with the bottom set of numbers being in parentheses. You have to have whatever is inside of the parentheses be exactly the same in order to cancel. So if we look at the top here, I have x squared plus 4x minus 12. I want to factor that. Ignoring the bottom right now. So factors of negative 12 that add up to give me 4 would have to be 6 and 2. And the 2 would have to be the negative number because 4 is positive. Since the leading coefficient is 1, I can go ahead and simplify and factor this. So I have x plus 6 and x minus 2. That takes care of the top. It is completely factored. Now let's look at the bottom. I only have 2 terms, so I want to look and see if I have a greatest common factor between the terms. I have a 3 and a 6, so the 3 can factor out of both terms. When I divide both terms by 3, I end up with x minus 2. Now, if I can cancel things, I should. Again, the entire set of parentheses must be the same in order for you to cancel. So I notice in the top and the bottom of this equation, I have an x minus 2. The x minus 2's cancel each other out, and you're left with x plus 6 on the top and 3 on the bottom. You cannot cancel the 6 and this 3 unless you also divide the x by 3. So you could say this if you wanted. That's equivalent. But either answer would be acceptable. Before we can do any operations with rational expressions, we need to review some things about fractions, because essentially that's what we're dealing with, just fractions with variables in them. Whenever we're multiplying fractions, so let's say I have 2/3 times 10 6. I want to multiply straight across the top of this fraction and straight across the bottom. So 2 times 10 is 20. 3 times 6 is 18. And this would be my resulting fraction. If ever I have a fraction, I should reduce it. Both of these numbers can divide by 2, so I have 10 over 9. Dividing fractions is similar multiplying fractions, except for one key step. Whenever I'm dividing by a fraction, I always want to multiply by the reciprocal of the second fraction. So in this case, the 10 over 6. That's going to become 6 over 10. And then I multiply straight across the top and straight across the bottom. So on the top of this fraction, I have 12. On the bottom, I have 30. And I need to reduce that. Both numbers can divide evenly by 2. So this reduces to 6 over 15. And it looks like it can reduce again. Both numbers can divide evenly by 3. So that's 2 over 5. So whenever you are multiplying fractions, you multiply straight across the top and straight across the bottom. Multiply the numerators and the denominators. When you're dividing, you flip the second fraction and multiply by the reciprocal. Whenever you want to perform operations with rational functions, you always want to factor and do any canceling that you can first. It's going to save you time in the end. So let's look at this expression. I have 2 fractions, both with x's in the numerators and the denominators. So the first thing I'm going to do before I do anything is try to factor. So I'll focus here on the top. I have the 2x squared plus x minus 6. So I want factors of negative 12 that when I add up, I get 1. So that has to be 3 and 4, and the 3 would have to be negative. So I'll split the middle term up. 2x squared minus 3x plus 4x minus 6. And then factor by grouping. The first group, I can pull out an x. And I'm left with 2x minus 3. The second group, I can pull out a 2, a positive 2, and I'm left with x minus 3 again. So the two factors on the top of this fraction are 2x minus 3 and x plus 2. X minus 3 and x plus 2. So I factored that top. So I'm done with that one. So let's factor the bottom. The leading coefficient's 1, so I just have to think of factors of negative 5 that add up to give me 4, which would have to be 5 and 1, and the 1 being the negative number. So on the bottom of this first fraction, I have x plus 5 and x minus 1. Now let's look at the second fraction. Focus on the top. I only have 2 terms, so I want to think about a greatest common factor. I always want my x terms to be positive. So I'm going to factor out a negative x here. So on the inside of this fraction, I'm left with positive 3x minus 2. On the bottom here, again, I only have 2 terms, so I want to think about a greatest common factor. And notice both coefficients are divisible by 2, and they both have an x, so I'm going to factor out a 2x. And I'm left with 3x minus 2. Since we're multiplying these two equations, or these two expressions, we're going to end up multiplying across the top and across the bottom. So I can basically cancel out anything that I can. I notice I have a 3x minus 2 in the top and the bottom here. I don't have anything to cancel in this first fraction. In the second fraction, I can cancel out the x's. I'm still left with a negative. So on the top, I have negative 3, on the top, I just have a negative 1, and then these 2 terms. And on the bottom, I have an x plus 5 and an x minus 1. If I could simplify anything further, I should, but it doesn't look like I can, so this would be my final answer. We'll talk about this more in class, so make sure you write down any questions that you have.